In this video, you'll learn about C++ access specifiers. Access specifiers are a key part of object-oriented programming. They help control access to the members of a class. We'll cover the basics of public, private, and protected access specifiers and how they're used. Access specifiers in C++ are keywords that set the access level for class members. They control which parts of a program can access class members and are fundamental to encapsulation in object-oriented programming. Access specifiers help maintain data integrity and security. Consider the example of a person class. The age and social security number, or SSN, fields are marked as private, meaning they can only be accessed from within the class. The name and address fields are marked as protected, meaning they can be accessed from within the class and any derived classes. The setAge and getAge methods are marked as public, meaning they can be accessed from anywhere. There are three main access specifiers in C++: public, private, and protected. Public members can be accessed from anywhere in the program. Consider the person class example here. The name variable is declared public. So this variable can be accessed from any part of the program. Private members can only be accessed from within the class. In the person class example, the age and social security number variables are declared private, so these variables are only accessible from within the person class. Protected members are accessible within the class and any derived classes. In the person class example, the address variable is declared protected. So, this variable is accessible from within the person class and any class that inherits from the person class. Public members are accessible from anywhere in the program. They are typically used for interface methods and properties, like getters and setters. Public members represent the class's public application programming interface or API. Let's look at an example using a student class. The name variable is public, as are the setGrade and getGrade methods. The grade variable itself, however, is private. This means you can access and modify the name directly from anywhere. You can also set and retrieve the grade using the setGrade and getGrade methods, but you cannot directly access the grade variable. Private members are only accessible within the class itself. They're hidden from outside code and derived classes. This protects internal data from modification, which is fundamental to encapsulation. If no access specifier is specified, private is the default. Here's an example using a bank account class. The balance, account number, and PIN variables are private. The deposit and getBalance methods are public. This means you cannot directly access or modify the balance, account number, or PIN variables from outside the class. However, you can deposit money and check the balance using the public methods. Protected members are accessible within the class itself and in derived classes. They are not accessible from outside the class hierarchy. This enables inheritance while maintaining encapsulation, balancing security and extensibility. Take, for example, a shape class with width and height as protected members. The constructor is public. A rectangle class inherits from shape. Because width and height are protected, the rectangle class can access them to calculate the area, but outside code cannot access them directly. Let's compare the three access specifiers to clarify who can access what. Public members are accessible from within the class, from derived classes, and from outside classes. Protected members are accessible from within the class and from derived classes, but not from outside classes. Private members are only accessible from within the class. As a reminder, if no access specifier is specified, the default is private for classes and public for structs. When using access specifiers, it's best to make data members private by default. Use public methods to access private data, such as getters and setters. Use protected for members needed by derived classes. Keep the public interface minimal and well documented. Always follow the principle of least privilege, granting only the necessary access. Here's an example of a well-designed employee class. The name, ID, and salary variables are private, and there are public methods to get these values and to raise the salary. The internal data is protected, but there is still a way to interact with the class. To summarize, access specifiers control the visibility and accessibility of class members. Public members are accessible from anywhere. Private members are only accessible within the class. Protected members are accessible within the class and derived classes. Why does this matter? It enables encapsulation, hides implementation details, protects data, allows changing implementation without affecting the interface, and controls what derived classes can access. If you want to learn more, check out the C++ reference documentation, C++ Primer by Stanley Littman, and the C++.com tutorial on classes. Common pitfalls to avoid include forgetting that class members are private by default, making all members public, which violates encapsulation, using protected when private would be more appropriate, and not providing proper accessor methods for private data. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.